Welcome to AI Frontiers, where we explore the cutting-edge developments that are reshaping our world. Today we're examining a computer vision revolution where fairness meets performance through 16 groundbreaking papers that are redefining AI's visual intelligence. These papers tackle everything from medical AI bias elimination, while actually improving accuracy, to controllable video generation with unprecedented precision. We'll explore foundation models, bridging images and video understanding, safety-critical AI systems for autonomous driving, and efficient models designed for resource-constrained deployment. This isn't just technical progress, it's a transformation that promises to make AI both more powerful and more equitable. Picture a hidden crisis unfolding in hospitals worldwide, when life-saving AI systems fail certain patients based on their demographic characteristics. Hospital AI systems are more likely to miss critical conditions in women compared to men, and elderly patients consistently receive less accurate diagnoses than younger ones. This demographic bias has become deeply embedded in medical imaging systems, perpetuating healthcare disparities that have existed for generations. However, researchers have just cracked what many thought was an impossible code. They've discovered how to eliminate this bias while simultaneously improving overall performance. This breakthrough challenges the fundamental assumption that fairness comes at the cost of accuracy, proving instead that both objectives can be achieved together. October 12, 2025, marked a breakthrough publication day in computer vision research, with 16 papers defining the future of how machines see and understand our visual world. These papers span an incredible range of applications, from medical AI systems to autonomous vehicles, each representing months or years of painstaking research and experimentation. The discoveries encompass fairness and bias mitigation breakthroughs, efficiency optimizations for real-world deployment, reliability advances for safety-critical applications, and generative models offering unprecedented control over visual content creation. Together, these papers reveal a field undergoing remarkable transformation, with real-world deployment solutions finally emerging from laboratory settings. Computer vision represents the ambitious goal of teaching machines to see, much like teaching a blind person to perceive the world through touch, sound, and every other available sense. This field serves as the crucial bridge between our digital and physical worlds, enabling technologies we now take for granted. Face recognition systems that unlock our phones, medical diagnosis tools that help doctors spot tumors in scans, and autonomous navigation systems that guide vehicles through complex intersections. Modern computer vision systems often possess superhuman pattern detection capabilities, processing visual information at speeds impossible for humans, while spotting subtle patterns that escape even expert observers. The field has been revolutionized by deep learning techniques that can replace thousands of lines of hand-coded algorithms, with neural networks trained on millions of examples. The first major theme emerging from these papers focuses on a fairness revolution in medical AI, exemplified by the groundbreaking work of Mottez and colleagues. Their research tackles chest X-ray AI systems that have been perpetuating healthcare disparities, systematically providing less accurate diagnoses for certain demographic groups. The elegance of their solution lies in its simplicity, replacing just one component of the neural network, a simple classifier, completely fixes the bias problem. Think of it like tuning a musical instrument. They don't just eliminate the discordant notes that favor some patients over others, but they make the entire system play more beautifully for everyone. This work fundamentally challenges the long-held assumption that fairness necessarily costs performance, providing instead a practical toolkit that healthcare institutions can implement in their existing deployed systems. The second dominant theme revolves around foundation models, bridging visual domains, as demonstrated by Lee and colleagues' innovative approach to video understanding. Their work exemplifies a strategy similar to teaching someone to become an expert chef by first making them an expert food critic, leveraging existing knowledge to master new domains more efficiently. The researchers have successfully extended powerful image language models to comprehend video content, utilizing knowledge learned from static images to understand dynamic scenes. This approach represents massive computational savings compared to training video understanding models from scratch, which would require enormous datasets and processing power. The resulting systems are not only more efficient, but often more effective than models trained specifically for video tasks. The third theme showcases controllable video generation mastery through Chen and colleagues' demo framework, which offers puppet master-level precision over talking portrait videos. Their system provides independent control over every aspect of facial movement, head tilt, lip synchronization, and gaze direction, all while maintaining perfect coordination between these elements. The applications are transformative, enabling personalized avatars for communication, sophisticated dubbing systems for entertainment, and accessibility technologies for individuals with speech impairments. What makes this achievement remarkable is the perfect temporal coherence achieved through motion disentanglement. The system can manipulate individual facial features independently, while ensuring the overall result remains naturally coordinated. This technology transforms what was previously confined to science fiction into practical reality. The key findings from these papers represent paradigm-shifting discoveries that challenge fundamental assumptions in AI system design. The most remarkable breakthrough demonstrates that replacing just one neural network component can simultaneously fix bias problems and improve accuracy, a discovery that seemed almost too good to be true. Researchers achieved independent facial motion control with perfect temporal harmony, solving what appeared to be an impossible engineering challenge. Perhaps most importantly for safety-critical applications, the research reveals that accuracy and stability represent separate performance dimensions, meaning a system can be highly accurate on average while dangerously unreliable in specific situations. Additionally, unified systems have been developed that excel at both understanding existing visual content and generating new material, while automatic corner case detection systems can identify problematic scenarios without requiring manual categorization. Today's featured paper presents comprehensive bias mitigation research by Mottez and colleagues, which is transforming medical AI fairness in unprecedented ways. Their work addresses how medical AI systems have been perpetuating healthcare disparities that have existed for centuries, systematically providing inferior care to certain demographic groups. The elegance of their solution cannot be overstated. They discovered that replacing the final classification layer with an extreme gradient boosting classifier eliminates bias while improving overall performance. This approach is like changing a camera lens that not only eliminates optical distortion, but actually improves image quality across all lighting conditions. The researchers validated their method across multiple medical conditions and different neural network architectures, proving that their improvements represent fundamental insights rather than fortunate accidents. Most importantly, their solution enables practical implementation without requiring complete reconstruction of existing deployed systems. The technical innovation behind this breakthrough combines extreme gradient boosting with active learning to achieve both fairness and accuracy simultaneously. The researchers conducted comprehensive comparisons against traditional bias mitigation techniques, including adversarial training methods that attempt to fool systems into ignoring demographic information, reweighting strategies that adjust the importance of different training examples, and data augmentation approaches that artificially balance datasets. The clear winner emerged as their XGBoost replacement combined with active learning, which produced the largest bias reduction across all demographic groups, while maintaining superior diagnostic accuracy. This approach extends far beyond medical imaging to any high-stakes application where fairness matters, providing a practical framework that institutions can implement to audit and improve their existing AI systems without starting from scratch. The most revolutionary insight from this research concerns where bias actually resides within AI systems. The success of their approach reveals that bias typically emerges not from the feature extraction process, the deep neural network layers that learn to recognize patterns in images, but from the final decision-making component. This discovery suggests that the sophisticated pattern recognition capabilities of deep networks remain largely unbiased, while discrimination occurs during the final classification step. This insight opens entirely new research directions and suggests that bias mitigation might be far more tractable than previously believed. The implications are profound. Fairness and accuracy are not competing objectives, but complementary goals that can be achieved through thoughtful system design. Healthcare institutions can now audit their existing systems and implement effective bias corrections without rebuilding their entire AI infrastructure. Looking toward the future, these research themes converge like rivers flowing into a mighty ocean, pointing toward a computer vision landscape that promises human-level visual understanding with equitably distributed benefits. We can envision autonomous vehicles that don't just avoid accidents, but actively contribute to creating safer transportation systems for all members of society. Medical AI systems will not only diagnose diseases with unprecedented accuracy, but help eliminate the persistent healthcare disparities that have plagued medicine for generations. The efficiency improvements demonstrated in these papers will enable sophisticated AI capabilities to run on everyday smartphone devices, democratizing access to advanced visual intelligence. Perhaps most importantly, we're approaching an era of trustworthy AI systems that are not just more powerful, but more aligned with fundamental human values of fairness and equity. We are witnessing a golden age of visual intelligence, where technical progress serves humanity's best interests rather than merely pushing performance metrics. The research demonstrates that fairness and performance can be achieved simultaneously, challenging decades of assumptions about necessary trade-offs in AI system design. Sophisticated generative models now offer unprecedented control over visual content creation, opening new possibilities for human-computer interaction and creative expression. Real-world deployment solutions are emerging for safety-critical applications, with robust evaluation frameworks ensuring reliable performance in unpredictable conditions. Most encouragingly, researchers are carefully considering the human impact of their innovations, not just optimizing technical metrics. The future of AI is being shaped not only by brilliant researchers in laboratories, but by society's collective voice in determining how these powerful technologies should be developed and deployed. This content was created through collaborative human-AI processes, designed to ensure accuracy and accessibility. AI synthesis was performed using Claude Sonnet 4 from Anthropic, providing comprehensive analysis and synthesis of the research papers. Text-to-speech synthesis is powered by advanced deepgram technology, optimizing the content for clear audio delivery. Image generation utilizes OpenAI's sophisticated visual generation systems to create relevant illustrations. Throughout the process, human expert review and oversight were conducted to verify technical accuracy and ensure appropriate presentation of complex research findings. While we acknowledge the potential for oversights in this synthesis process, all original research references are provided for those who wish to explore the primary sources in greater detail. Thank you for joining us on AI Frontiers as we explore these remarkable advances in computer vision research. Subscribe for daily AI breakthrough analysis and stay at the forefront of technological innovation. I encourage you to explore these papers yourself. Many are freely available online through the archive preprint server, and each offers insights that could spark your own ideas or applications. Share your thoughts about these developments with others, because the future of AI isn't shaped solely by researchers, but by all of us as we consider how these technologies should evolve. Join the conversation shaping AI's future, because your voice truly matters in determining where we go from here. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive-preprintserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive-preprintserver.org.